This is a review of linear equations. For my students, this is a review of chapter 5 in their textbook. Excuse me. So it's got direct variations, has point slope form, has slope-intercept form, standard form, and then parallel and perpendicular lines. So those are all the topics covered here. So the first piece here is how do you find the slope of a line when you're given 2 points? And so remember, the formula for finding slope when you're given 2 points is that the slope equals y2 minus y1 over x2 minus x1. And so for each of these, my recommendations to my students is always to label these. So x1, y1, and x2, y2. And you could call this x2, y2, and this one x1, y1, that's fine. You just can't call this x1 and this y2, right? So 1 means that's your first point, 2 means your second point. And it doesn't matter which one is your first one and which one's your second one. And then once you've labeled them, then you just plug them in to this formula. So we would do 1 minus negative 2. So it's y2 minus y1. So 1 minus negative 2 over x2 minus x1. So 1 minus negative 2 is 3, and 3 minus negative 2 is 5. And so the slope is 3/5. It's a positive slope, so remember that means it's leaning to the right. Same thing on this one, x1, y1, x2, y2. So I would do negative 1 minus 3 over 2 minus 2. So that comes out to negative 4 over 0. Dividing by 0, if 0 is in the denominator, the slope is undefined. So this has an undefined slope, and you can do a 0 with a slash through it. That also means undefined. Remember, this is actually a vertical line. So a vertical line has an undefined slope. If you're not sure if it's undefined or if it's 0, do negative 4 divided by 0 in your calculator, and it'll give you an error. That tells you it's undefined. All right, so here we go, x1, y1, x2, y2. So I have negative 1 minus negative 4 over 2 minus negative 3. So that comes out to 3/5, and so the slope is 3/5. Just so happens to be the same as number 1. Number 4, here we go, x1, y1, x2, y2. So I have negative 1 minus 3 over 2 minus 2. And that one comes out to negative 4 over 0. And that one is also undefined. So I kind of messed up. I should have put an example in here where the numerator was, that's actually 2 and 4 are actually the exact same problem. So I meant to switch these around. I have to fix that. If 0 is in the numerator, then the slope is 0, because 0 divided by anything is 0. All right, so that's why a mistake. If 0 is in the denominator, it's undefined. 0 is in the numerator, it's 0. All right, how do we find the slope of a line if we're given a graph? So if we're given 2 points, we use this formula, y2 minus y1 over x2 minus x1. If we're given a graph, then what we're going to use is that slope equals rise over run. And the other thing we're going to use is that a line leaning to the right, m is positive, and a line leaning to the left, m is negative. All right? So this first one, number 5, is a positive slope because it's leaning to the right. We can choose any 2 points on this line to find the slope. So it doesn't matter if I do rise over run between the first 2 points or the last 2 points or the middle 2. They all will simplify to the same slope. So let's use we'll use this point here, and we'll use this point here. All right. So the rise is 1, 2, 3, 4. It's the number of blocks that you go up. So you go 1, 2, 3, 4 blocks, and so that's the rise. And the run is 1, 2, 3, 4, 5, 6. And so for rise over run, it would be 4 over 6, or 2/3, and it's positive because the line's leaning to the right. Right, this next one, I know the slope is going to be negative because it's leaning to the left. I was only given 2 points here, so I'm going to use those 2 points. Again, on the last one, I could have used any of the points and they all would have simplified to 2/3. So this one has a rise of 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5. So the slope, rise over run, is negative 4/5, and it's negative because the line's leaning to the left. All right, so let's look at direct variation. So the form of a direct variation is y equals k times x. And I'm just going to write here where k is equal to y divided by x. So suppose y varies directly with x. They're telling us that this is a direct variation. Write a direct variation equation that relates x and y. All right, so all we need to write an equation in direct variation, it's the simplest linear equation there is we need to find this k value. And the k value, like I just said, is just y over x. So in this case, that would be 3/4. So the equation is y equals 3/4 times x. And then later on, we learned that in other forms of linear equations, we don't call this k, or the constant of variation, we call this the slope. So this is really the slope of the line. Same thing on this one. So we do y over x. So y is 3, x is -5. And so the equation of the line is y equals -3/5 times x. This is a negative constant of variation, negative slope. So this line leans to the left. This line leans to the right. All right, the other piece is, what if you're given some data and asked if this data is a direct variation? So for the data in the table, tell whether y varies directly with x. If it does, then write the equation. So what you're looking for is there a constant of variation? That's what k stands for. In other words, is y over the x the same for all of the ordered pairs here? So what we're going to do is find k, y over x for all of these. So -1.2 divided by -1 is positive 1.2. 2.4 divided by 2 is 1.2. I don't know why. 5.6 divided by 5. That is not 1.2, I don't think. Let me get my calculator here. 5.6 divided by 5 is 1.12. So the answer to this is no. It says, tell whether y varies directly with x, and the answer is no, it doesn't, because there's not a constant of variation. So let's look at the next one. So again, we're going to find if there is a constant of variation, y over x. So 1.5 divided by 3 is 0.5. It's actually negative 0.5. 0.5 divided by -1 is negative 0.5. -1 divided by 2 is negative 0.5. And negative 1.5 divided by 3 is negative 0.5. So this one is yes. And then it says, if it's yes, write an equation. And the equation is just y equals negative 0.5x. So again, direct variations are the simplest form of linear equations. Just y equals k times x, where k is the constant of variation, and k can be found by doing y divided by x. All right, the next piece here says write an equation in slope-intercept form of the line that passes through the given points. So slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So this is the slope, and this is the y-intercept. So in order to write the equation in slope-intercept form, we need to find the slope and the y-intercept. So if we have 2 points, we can find the slope using the slope formula, which is y2 minus y1 over x2 x root 2 x2 minus x1. All right, so that'll give us the slope. So let's go ahead and do that. So again, I'm going to label these x1, y1, x2, y2. So the slope would be -5 minus -4 over -3 minus 2. So the slope is -1 over -5. Let me double check that. Let's see, -1, -5, which those two negatives cancel each other out, and so the slope is really +1/5. So I know the slope now. Now I need to find the y-intercept. So to find the y-intercept, what I'm going to do is plug one of these points in and this slope in to there's 2 ways I can do this. So I'll do this one. This one I'll plug it into the slope-intercept form to find b. The next one I'll plug it into point slope form, and no, that won't give us b. So I scratch that. We're just going to plug it into slope-intercept form. So we're going to take y equals mx plus b, and I'm going to plug one of these points in. I'll choose the first one. So I'll plug in -4 for y. Again, I'm plugging it into this form, slope-intercept form, equals the slope, which we just found was 1/5, times the x value, which is 2. And again, let me say, I could use this point. This would work also. I can use either one of these points, and that will give me the same value for b. And then plus b. All right, so let's multiply this out. I get -4 equals 2/5 plus b. Running out of room here. Let me extend this. So now I'm going to subtract 2/5 from both sides. Minus 2/5. So -4 minus 2/5. Put that in my calculator. And I get 2/5. So b is equal to 22/5. And remember, in algebra, we're okay with improper fractions. So there's my b value, b, and here's my m value. And remember, that's what I needed to write this equation in slope-intercept form. And so now I just write the equation y equals mx, m is 1/5, plus b, which is 22/5, and that's the answer. There you go. So again, let me say I found the slope using the slope formula, y2 minus y1 over x2 minus x1. Then I plugged that slope, and I plugged one of the points into the slope-intercept form and solved that for b. So let's do the same thing again. So x1, y1, x2, y2. Slope is y2 minus y1 over x2 minus x1. So the slope is 3/7. So now I'm going to plug that slope, and I'm going to plug one of these points in. And I'm going to use the second point, the one with the positive numbers, just because I'd rather work with positive numbers if I can. So the y value is 1, just plugging it into the slope-intercept form. So I'm plugging in 1 for y, plug in the slope, plug in the x value, which is 4, and then plus b. So go ahead and multiply these together. I get 1 equals 12/7 plus b. Subtract 12/7 from both sides. And so 1 minus 12/7, let's see, 1 minus 12/7 is negative 5/7. So there's my p value, my y-intercept. Here's my slope. And then I just plug those in. Y equals negative, sorry, it's mx. So 3/7 times x. And then since this is a negative 5/7, I put minus 5/7. All right. So let's see what we got next. All right, so writing an equation from a graphed line. It doesn't say what form I need to use. So I need to think about all the forms I have. I have point slope form. Let's start with the one we already did, slope-intercept form. For that one, I need the slope and the y-intercept. I have point slope form, which is y minus y1 equals m times x minus x1. And then the other form I have, which is the least useful form, is ax plus by equals c. That's standard form. So looking at this, I got to decide which form I want to use. And you're typically going to either use slope-intercept form or point slope form. Slope-intercept form, if you just look at it, looks easier, right? But here's the problem why I can't use slope-intercept form on this first one. The problem is I don't know what the y-intercept is because it crosses in between the grid lines. So I don't want to use slope-intercept form. In fact, I can't use slope-intercept form, not easily. So it'd be better to use point slope form because I can find the slope using rise over run. And then for a point, x1, y1, I can just use any of these 3 points. All right. So let's use point slope form for this one. So I'm going to do rise over run. This is a positive slope. It's leaning to the right. So I'm going to rise 2, and I'm going to run 1, 2, 3. So the slope of this line is 2/3. And then for the point, I can use any of these 3 points. So that means there's 3 different answers you could get. Now, if you were to simplify those answers and put them in slope-intercept form, they all would simplify to the same thing. Okay, but again, this didn't say what form I needed to write the answer in. So I can leave it in point slope form. So the equation in point slope form would be y minus, and now I need to pick which point I want to use. Let's use the point with positive values. So this point is 2, 4. The x value is 2. This is the x. This is the y. And so for y1, I'm going to plug in 4. So y minus 4 equals m, which is 2/3, x minus the x1 value, which is 2. And that would be your answer. That's your answer in point slope form. Now, if they asked you to put the answer in slope-intercept form, I'm just going to show you. This doesn't say you have to do it. But to put this into slope-intercept form, you need to solve this for y. And the way you would do that is to distribute here. So you'd have y minus 4 equals, I don't know why I put 2 equal signs there. 2/3 x minus 4/3. I'd add 4 to both sides. So plus 4 plus 4. And I'd have y equals 2/3 x plus, let's see, that's 1 1/3, so that would be 2 2/3. I think that's 8/3, but I'm going to check it on my calculator real quick. Yep, it's 8/3. So this is your answer in point slope form. Slope. And this is your answer in slope-intercept form. All right. So I first put it in point slope form because I have points and I can find the slope. And then if they asked me to write my answer in slope-intercept form, I would solve the equation for y, and that would put it in slope-intercept form. All right, so let's look at this next one. This next one, I have a y-intercept. So the y-intercept is 4. So let's just go ahead and write this in slope-intercept form because I have the b and I can find the slope using 2 points. All right, so find the slope. Let's do rise over run. By the way, the slope here is negative because the line's leaning to the left. So I rise 2 and I run 1. So the slope is -2. 2 over 1, it's negative because it's leaning to the left. And so for this one, to write the equation, I would just write y equals -2x plus 4. So that one's easier. So if you have the y-intercept, it's much easier to write it in slope-intercept form. All right, what do we got next? All right, so graphing. So y equals 3x minus 1. So you need to recognize that this is in slope-intercept form. So they've given you the slope of 3 and the y-intercept of -1. So the slope is 3 over 1. That's rise over run. And the y-intercept is -1. So what you want to do is graph the y-intercept first, crosses the y-axis at -1, and then you want to do rise over run. So I rise 3, 1, 2, 3, and I run 1. And now do I run to the right one or to the left one? It's a positive slope, so I know the line needs to lean to the right. So 1, 2, 1, 2, 3, and then 1. And then you just draw a line through this. Let me get my fancy line here, maybe. And I draw a line through this. I'm very good with my line. Let's see if I can do better. That's good enough. And you should put arrows on the end of this because the line continues indefinitely in both directions. So that's number 15. All right. For number 16, x equals 2. This is either a horizontal or a vertical line. And the way that I remember is I say, okay, well, I know it goes across the x-axis at 2. That's right here. If I was to draw a horizontal line, it would go through every x value. But it says that x is 2. So for x to only be equal to 2, it's got to be a vertical line. So it only goes through the y-axis, or the x-axis, I'm sorry. Only goes through the x-axis at 2. So this is a vertical line. So that's number 16. Number 17 is in point slope form. So the slope is 2. I'm going to write 2 over 1 because we're going to use rise over run. Rise over run. And this is my y1 and this is my x1. And point slope form is y minus y1 equals m times x minus x1. So if there's a plus sign here, that means that y value was negative, because a negative and a negative make a plus. If it's a minus sign, then that's a positive value. So the point that this goes through is 1, negative 3. The x value is positive 1, the y value is negative 3. So I'm going to graph that point that it goes through first, 1, negative 3, right there. And then from that point, I'm going to do rise over run. And again, this is a positive slope, so it leans to the right. So I'm going to go up 2 and to the right 1. Let me draw my line. Again, I get arrows on the end because the line continues in both directions indefinitely. All right, last one. So this is in standard form. Again, standard form is ax plus by equals c. And it's the least useful form because it doesn't really tell me anything I can use to graph. So here's how you graph things that are in standard form. I'm going to pause this 1 second because I want to make a little box. So hold on one. All right, so here we go. So to graph an equation in standard form, the easiest way to do it, you could solve this and put it in slope-intercept form and graph it that way, but there's an easier way. The easier way is to recognize that the x-intercept of the line occurs where y is 0, and the y-intercept occurs where x is 0. So if I take a box, and what I say to do to my students is just put your thumb over one of the values. So this would, if x was 0, this would go away. And what you'd be left with is 4y equals 8. So 4y equals 8. Divide by 4 and you get y equals 2. That is the y-intercept. Then do the same thing with the y value. So the x-intercept occurs where y is 0. So I cover up the y value and I get 2x equals 8. So solve that, you get x equals 4, and that's the x-intercept. So this line crosses the y-axis at 2 and the x-axis at 4. So let's go down here. This is number 17. This is number 18. It crosses the y-axis at 2. It crosses the x-axis at 4. So that's right there. And so then I draw my line through those. Get my line back. Line, da, 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 da. Draw through those. Extend this out. Put my arrow. And that's that. So a lot of information there. So if you need to back up and watch it again, okay? All right, last piece. Write an equation of the line that passes through the given point and is parallel to the graph of the given equation. Now here's the key. Parallel lines have equal slopes. Parallel lines have equal slopes. So if you have two lines that are parallel, those are supposed to be straight. Just pretend they're straight. They have the same steepness. They have the same slope. All right. So here's an equation of a line. This is actually a direct variation. And they want us to write an equation of a line that passes through this point and is parallel to this. And it doesn't say what form they want it in. So I can leave the answer in whatever form I want. This, you need to recognize, is the slope. So the slope is 5, and it goes through this point. So let's use point slope form. slope form is y minus y1 equals m times x minus x1. So this is my x1, y1, and this is my slope. So I just plug those in. So y minus -5 would make y plus 5 equals the slope, which is 5, times x minus 0. So same slope going through this point, that would be your equation. Now, if they asked you to write this in slope-intercept form, then you need to solve this for y. So you would distribute and then subtract 5 from both sides. But it didn't ask us to do that. All right, so one more. This one is in slope-intercept form. So that's my slope. That's the y-intercept, which I don't need. And then this is my x1, y1. So the equation would be y minus -1, so that's y plus 1, equals m times x minus x1, which is 2. There you go. Determine whether the graphs of the two equations are parallel, perpendicular, or neither. So parallel, we already said, has slopes. Perpendicular, the slopes are opposite reciprocals of each other. Slopes are opposite reciprocals. So if the slope of one line is 2/3, the other one will be -3/2. So they're reciprocals, meaning they're fractions flipped over, and opposite means if one's positive, the other one's negative. So on this first two here, these first two equations, this is the slope of this one, which is 6. This one is in standard form, so I'm going to solve it for y and put it in slope-intercept form so I can see what the slope is. So I'm going to put it in this form. This one's already in slope-intercept form. This one's in standard form, so I'm going to solve it for y. So I'm going to get y by itself, so I'm going to subtract 18x from both sides. And so now I have -3y equals 15 minus 18x. Divide everything by -3. Again, I'm solving it for y. So I get y equals negative divided by negative is a positive, equals -5. This is a minus and a negative, that makes a plus 6x. And then to make this in true slope-intercept form, I'm gonna flip these two around. So 6x minus 5. And so you can see the slope of this line is 6. So since they have equal slopes, that means they're parallel. Equal slopes are parallel. All right. So similar thing over here. So again, in standard form. So let's solve it for y. So -2x minus 2x. So I have -5y equals 0 minus 2x would just be -2x. Then I'm going to divide by -5. So I get y equals 2/5 times x. So the slope of this line is 2/5. All right, this next one, let's subtract 3 from both sides. So -3 minus 3. Again, I'm putting it in slope-intercept form. So y equals 5/2 x minus 3. And this is one of the most missed questions that I get here. These two slopes are reciprocals of each other, but they are not opposite reciprocals. And they're not equal. So these are not parallel or perpendicular. So the answer to this would be neither. In order for these to be perpendicular, this would have to be, one of these would have to be negative to be opposite reciprocals. All right, and then the last thing I have for you here Write an equation, a line that passes through the given point and is perpendicular to the graph of the given equations. So perpendicular, again, the slopes are opposite reciprocals. So the slope of this line is -3. So the slope that I want to use for my new line is +1/3. So opposite reciprocal, think about this. This is really -3/1. Take the reciprocal, you get -1/3, and then you take the opposite. So it's +1/3. So the slope of my new line has to be +1/3. Here's my x1 and y1. So I'm going to use point slope form. So again, point slope form is y minus y1 equals m times x minus x1. So plug those in. So y minus 5 equals 1/3. That's a terrible equal sign. Times x minus 3. And so that's the equational line that's perpendicular to that one. All right, same thing here. The slope of this is 8. So the slope that I want to use is -1/8. Again, 8 is the same as 8/1. Opposite reciprocal would be -1/8. Here's my x1, y1. So y minus 10 equals -1/8. It's an 8, I promise, times x minus 4. All right, a lot of information there. So I hope that that was helpful to you. If you need to back up and watch anything, please do. Give it a like and a subscribe if this was helpful to you. And feel free to leave me a comment. Until next time.